As you probably heard, we are from Prague, Czech Republic. My name is Petr and this is my colleague Michal Vanek. We are both from AVAST Software, which is a software company which does AVAST antivirus software, and it's known for it. It's worldwide known right now, but still it's located in the Czech Republic. We both work in quality assurance department, and the main topic of our presentation is going to be why and how did we use or do we use Jenkins in quality assurance. As the title says, Jenkins is now a humble servant of quality assurance department. It wasn't like that since the beginning, and we're using Jenkins as the backbone of our quality testing infrastructure. But it wasn't like this since the beginning. So I'll go through the agenda first. We'll show what do we test at AVAST. Michal's going to explain in detail how do we test it actually, and we'll go to the conclusion. So this is how department map looked to us when we first came to AVAST. This is the company when we first came. The gray thing in the middle, those are high gray concrete walls. It means no communication at all, and thus no integration. So let's go through departments. Virus Lab geeks use Perl. They love it. And if anybody of them doesn't love Perl, their boss makes them to love Perl. So they have to love Perl. Our development team produces the AVAST antivirus, the most important thing for us. And web guys, they like PHP, or I rather say they love PHP. They would like to have their own version control system implemented in PHP if it was possible. Luckily it's not. So last but not least is the cloud and development department, those guys who maintain our backbone servers and develop high performance Java applications. And the quality assurance department, the thing on the right side, that's us, and we do like write stuff in Python. So where would you put us? That's the question. We brought a friend with us from our previous job. His name is Jenkins, and the most important thing on this picture is that we placed him into the quality assurance department, not into other department. We couldn't fiddle with their existing ecosystems or existing build scripts. We could not do that because the company is running for 20 years now. So we just came and we had to start testing stuff. We couldn't change everything. So we placed Jenkins in quality assurance. You can see those thin black lines on the picture, and you can see the walls have miraculously disappeared. It looks like fairy tale, but we'll give to those lines some meaning later, and we'll get to that. So what were our tasks? We have many different products and services in AVAST antivirus. We've got some web services. We have to test them and use their REST API. We have to use this in test. We have to do server backend testing, and the most important thing is we have to run functional tests of the desktop antivirus software. I repeat that, functional test, not unit test, functional test. This antivirus software, we've got multiple editions or versions. We've got version which is for free version, customer version, business version. We support many operating systems since Windows 2000. And we've got also multiple testing suites we have to run. Add this or sum this up and you'll get huge metrics of configurations. We've got some other tasks like virus definitions, validation, and cloud feature testing. These are still functional tests of desktop applications, but they don't make sense unless they're integrated into some other environment. So what did we do with these tasks, and how does it look like from Jenkins' point of view? We find out that we can divide these type of tests into the three main groups. The first group of tests can be tested right on the same machine when Jenkins runs. That means simple configuration. That means simple scripts which are being executed from Jenkins shell. Again, one machine, one script stays on that machine. As I've mentioned on the previous slide, functional testing of desktop application cannot be done on the same machine as Jenkins runs. We've got that huge configuration matrix. So we have to run these tests on different machines than Jenkins runs, for example, on virtual machines. And as I've mentioned before, the cloud testing doesn't make sense unless we integrate our Jenkins jobs, our Jenkins tests into some infrastructure. I'll explain that in detail later.
I have a question.
Sure.
What do you use to manage this large amount of configuration metrics?
What do we use to manage these?
These configuration, you have so many variety of configs. How do you manage that?
Yeah, we do that from Jenkins actually. We've got like many virtual machines, and in those Jenkins jobs, we just download different builds of the. So we've got kind of pre-prepared environments. We download different editions, but we had to prepare all versions of Windows. Yeah, manually. Yeah. You can see that on this picture. Nice, simple picture. Let's focus at the middle, and let's find those three possible approaches from Jenkins' point of view. On the left side of the Jenkins box, there's a Python label. That means we run Python scripts on the same machine when Jenkins runs, and we run these tests against some servers. The STAF label stands for STAF framework, which we chose to connect to the testing machines, to the virtual clients, and we also use it to remotely control virtual machines, not just run tests, but also control machines. And as you can see, all those functional tests run on virtual machines, and there's a variety of applications and services. On the top of the Jenkins box, the REST API label means that other departments can programmatically control our Jenkins job. And that's the integration. Again, I'm going to explain that later. And now I'll pass my words to Michal, who's going to explain you the local execution and the remote execution. These are those two groups I've talked about earlier.
So, hello again from myself, and thank you, Peter, for the introduction. Now I would like to tell you something what will be in my terms local execution and remote execution. Well, all these terms are based on the point of view from Jenkins. So the local point of view means that tests are running exactly from the Jenkins bash. There are no other setup, no other configuration required. Just Jenkins machines, and that's all. By these tests, mainly written are scripting languages. We are testing our web services applications, and REST applications, and our backbone server infrastructure. Tests are mainly implemented in scripting languages because these brought us much more. It helps us to maintain the test very easily, and if something fails, then you might easily find out in which part of the code it fails. Some of guys in our department, they also prefer to use robot framework, and some of the tests are also written C++ and C++ and C#. Yeah. So how the configuration of the job for the testing purposes looks like. Yeah. The configuration of a job for the testing purposes is really the same like configuration for job for the building purposes. We are using all the Jenkins features as are used for building. So we have some build parameters, we have some build scheduling, we have build steps where we are running the test, and then we are publishing test results. Yeah. So you see, if you are using Jenkins for building or for testing, it's really very similar and almost the same. So I tell you the local execution means that all the tests are running from Jenkins itself. Nothing else is needed more. So does anyone from you know AVAST Web Wrap? Yeah, this one. Yeah. AVAST Web Wrap is a huge database of almost all websites all over the world and their ratings. These ratings are based on users' votes, and we use this rating to help people to be better protected when they are browsing websites. So if there is some page with a bad rating, we warn people that maybe if you would like to put a credit card number to this page, it's not recommended because probably the page is not very safe here. So this script tests our web app servers and tests the main functionality of web app servers, and it's the rating. But what is the more interesting is the Jenkins execution part. Yeah. By this script, which is above, we go through the servers and test them, ask for the rating and also for some other functionality, and then we log the results in some kind of log file. By using Jenkins, we can use the advantage of the build parameters and test them. So I hope that you can see the difference, that Jenkins is not building but mainly testing and nothing. The advantage and the reason why we have chosen Jenkins is the way how the test results could be published, yeah, and the big variety of the test result, because the most of our scripts are written in Python, and Python offers some kind of output which is very similar to jUnit. So you just simply check in the box for publishing test results, run the script, and then we can very easily to see that what are the test results of all our tests. So this is basically the whole local execution part. Yeah, we have a Jenkins job, which is parameterized. There are set up some build triggers, and in execute shell there is a script which tests some functionality. This functionality in our case is our web app servers or our complete remote assistant server backend. But what is much more important for us is a remote execution part, because AVAST antivirus is a desktop application and it has many versions, like we have a free version and some paid version. And all these versions has to run on different operating systems. So if you imagine this matrix, so on horizontal line we do have about 5-6 products, and vertical line we do have like 10 operating systems. So when we started in our department and when we started to find the solution how to automate AVAST, so what was the crucial task for us? So how to be able to run the tests for one build on different operating systems. So to solve this problem, we started to use some virtualization solutions. But because these virtual machines were outside of Jenkins, so then we struggled with the problem how to manage virtual machines outside of Jenkins, how to run the test there, and how to get the test results back. So then we started to using some framework which is called STAF, and I will talk about it later. If you look on a solution for the remote execution, in general, it looks like this: that executor of everything is Jenkins. That it manages the build triggering, running tests, and gathering results. As a virtualization solution, we have chosen VirtualBox because we have a good experience with VirtualBox from our previous company, and it fits perfectly for our situation. And then for the remote execution part, we have chosen a STAF framework. So if you see, if you imagine how this works, that there's one machine where Jenkins is running, and there is another machine with many virtual systems, virtual computers. And as a communication channel, we are using a STAF which is able to execute some processes error. It makes all the stuff what you want to do on a remote machine. To configure all this environment, the configuration of this environment is very easy. Just first, it's necessary to install STAF framework in all machines in a line. If you do not do this, so then you are not able to get from Jenkins to another machine and execute there some tests or installations. To be able to execute the test or install a product first on the machine where you are running your test, so then it's necessary to add some test machine parameter. Without doing this, it's not possible to run the test on a remote machine. And then the last important step, if you are using VirtualBox, is that it's necessary to configure port forwarding on a VirtualBox hot machine, so you are able to reach the virtual machine. I think that now finally we can start testing that. There are two basic operations what we are doing in Jenkins execute shell. The first is that we have to start remote virtual machine where we have some preset snapshot or with the basic configuration. Is for us for installation of AVAST and for testing AVAST is necessary to make sure that the machine is clean, and we know that if we make a clean installation of our product and it works on a clean installation, so it probably will work also with another configurations. But if it wasn't so, then it would be many cases that there might appear many problems like with unknown configuration. And when the machine is running, so the last thing what is necessary to do is to start up any process on a remote machine, or simply start the tests. With these tests, you want to test your application. Jenkins allows to use the VirtualBox plugin to control VirtualBox machines, but unfortunately this wasn't possible to be used in our case because VirtualBox has to be installed on the same machine as Jenkins is installed, and unfortunately it doesn't support reverse snapshot operation, and this operation is very important for us because we need to start on a clean environment, clean preset environment. So if you look on this in general, the situation looks like this. Jenkins first starts VirtualBox machine, then waits until the virtual machine starts up, and then it installs a product and runs the test. The last part is one of the most important part in here, because the tests are running remotely. You have your test outside of the Jenkins, and also the test results are outside of Jenkins. So when your test finishes, it is necessary to get the test results back to Jenkins. So then, that's why the last step is one of the most important. And if we have the test results back on Jenkins, then we are displaying them in a jUnit format or in robot framework. If you look on this picture, you may see that we ran 3 tests, and in build number 210, just one test failed. So because there is just a few of red, so generally we might say that the build condition is good. Unfortunately, we still have to solve the problem how to run the same test on different operating systems. Because we need to make sure that it's not possible to install AVAST just on Windows 7. We need to make sure that it's possible to install it on operating systems since Windows 2000, and believe me, Windows 2000 is not very friendly operating system these days. So to solve this problem, we have created something what do we call master job and multiple child jobs hierarchy. This is a simple application of parameterized trigger plugin. It's like for each operating system we create a job, and then we create a summary job, master job, which runs all these multiple jobs and wait until they end, and then it gives us some results and shows the result for the whole build. For some situations, we have found out that it's much better to use more master jobs than to parameterize job. The typical situation is that when you have internal build and some production build, which should be 99% the same, and you could use build parameterization. But if you would like to see the history of builds and to see that why some builds are failing wrong, so that's why it's better to use multiple master super. It's better. Simply, it's better to have more master jobs. Unfortunately, this master child job infrastructure brought us some problems with the test results evaluation. Yeah, because we are running the same sets of tests on a different operating systems, so it's not possible to use aggregating of the test results because the tests are the same, just from different operating systems. So we tried to use dashboard view plugin, but the problem with this was that it worked just for one master job. It wasn't possible to use this for more master jobs. And we also tried to use downstream build view plugin. Unfortunately, this was incompatible with parameterized trigger plugin. So if you would have any solution for this, just share with us. Luckily, there are many other solutions. What can we do with the test results? And this is my favorite one, because when we have shown the test results to the public in our hallway. After some time, actually it took us about 1 year, when we wrote enough amount of the test, we created a super job which we run at least once per day, and after running this job we are able to say what is the current build status. Green means okay, red means bad, and this is what our marketing people can understand. Yeah, and the last what I would like to mention is a Jenkins slave. Yeah, because I guess many of you are using Jenkins slave, so I guess that you would ask, why guys aren't you also using Jenkins slave for this? There are two main reasons. Yeah, we tried it, but the configuration of our solution for remote execution of tests on remote virtual machine was much more complicated than with STAF. And the main reason why we cannot use a Jenkins slave, or it would be possible but more complicated, is that it's not possible to reboot machine where Jenkins slave is running. And this operation is important for us because AVAST is mainly based on some drivers, and to be able to test these drivers is necessary to reboot the machine. And for some other systems like Windows XP, Jenkins uses more than slow amount of system resources, and that's why we are using STAF instead of slave. And now let me invite here Petr again, and he will tell you something about cloud testing.
So to sum it up, you should know by now how to execute tests locally. It's the same like building, and also remotely, also very similar, but you have to add STAF framework, and in our case, VirtualBox or any virtualization technology. So now we are going to use what we have learned. So if you haven't understand anything, it's probably better to ask now than later, but you'll have a chance to ask later. So I'll just continue with the cloud. So what's the cloud in our understanding? What do we mean by cloud? By cloud, we mean a place where we put a lot of stuff in or get a lot of stuff from. That's what we mean by cloud, and we use this thought heavily in our application. We use the AVAST web reputation, as Michal explained before, and we do have similar service which is called file reputation, also a huge database, and we've got also a feature which is called which we use for virus database distribution. It's called streaming updates. And I'm going to talk about these streaming updates because I've chosen it as an example of the cloud testing. So what was our goal? We have to integrate some small functional tests into the existing infrastructure of our virus lab department. Their built infrastructure is based upon Perl. All their scripts are in Perl. It's really a big pile of Perl scripts. And what they do, every 30 minutes, they release a small binary package of virus definition, and this binary package is distributed to our users all over the world. And we must not break their computers. We could easily do that with malfunction in virus definitions. You can have a small false positive in the virus definitions, and that means that the antivirus would, for example, take your Windows folder and put it in our virus chest, or program files folder into our virus chest. And that's something you don't want to do. We must not break their computers. We have to include some small functional test into this cycle. This is the scheme. How does it work? Virus App Geeks on the top release the small binary package. It gets to the cloud. It's just a network of computers, of backend servers, and they distribute the update instantly to users all over the world. They have an open, persistent connection to the cloud. They're waiting for this update, and they have to get it as soon as possible. So we have to keep this and still integrate our tests into it. So what we did, we combined everything we've just explained here the functional test of antivirus desktop application. We execute it remotely using the STAF framework and VirtualBox, and we added just one thing. We've integrated it into the existing build scripts. Another simple picture. So what's new here? The local cloud on the left-hand side is the same as the cloud on the right-hand side, but it's much smaller, and it's located into our private network. Instead of all those users down there on the right side, we've got virtual clients on our private network, and these clients are connected to the local cloud. And Jenkins also wasn't here, he is now. VirusLab released the binary package to the local cloud, and it gets distributed to all those virtual clients, and it stays there. Then they use Perl to call Jenkins REST API and execute a Jenkins job. This Jenkins job uses STAF framework to execute functional tests on a virtual client. Once this test finishes, the Jenkins uses STAF framework to gather jUnit test results back to Jenkins, and he interprets it using the REST API back to the VirusLab. And once this circle finishes, VirusLab guys get the status of the job, if it's okay or not. That's the only thing they care about, if it's okay or not. Now, I've got a really nice and simple script here, and it's in Perl. So in case you love Perl, you can go deep into it and download our presentation. But it's an end-to-end solution, as it was in those previous examples. So if you take those slides, I think you could just implement some kind of integration. I'll go really quickly through it. At the top, we've got some declaration of variables, which we are going to use later. We've got parallel HTTP agent, which is used into the next part to get next build number. We call Jenkins REST API. It returns us JSON object. We get the next build number from the JSON object, and then we run job on Jenkins. We wait for a while. There's the sleep there because Jenkins is pretty reliable, but some things take some time. So we wait until Jenkins executes this job, and then we just pull the build number we got in the first place until its result is one of possible results. So it's either successful or failure. The only thing which, yeah?
So any reason you don't use CLI? Because that, in my mind, that looks easier. Because you can just fork a process and then that locks until the build is complete, and you get the exit code and it creates the status.
Why don't we use?
The CLI, the command line.
Command line.
The REST API.
The command line. Because yeah, but it runs on different machine.
Yeah.
It's not executed from the machine when.
Yes, and CLI can talk to you on it.
Oh, okay.
Yeah.
Then we can possibly integrate it into the script and do the same thing.
So in our company manager, we couldn't use CLI plugin because of security issue, because we're afraid of someone like actually SSH to actually do some of the malicious stuff. So we kind of like depend on the REST API and
So just to make sure the CLI is also remote. You can run from your computer to talk to Jenkins or somewhere else. It supports the authentication via your SSH public key. So if there is any additional security concerns happening, that should be there. But it's quite adequate.
Yeah, so yeah, in our company we just have the paranoid and they're against kind of depend on the REST API and all these things. But I do think this kind of solution is like you have this like process like take every CPU. So it's actually what we are trying to do is like in the Perl is also using Perl as an event and you can trigger. So in our use case we are thinking about it maybe using Redis, and so we can use like in the hosting job and we can publish something, and then we can have like different jobs to subscribe those channels and then get the result. So I think it's a little bit better than the for loop thing.
Yeah, this is like the simplest example how easily it can be implemented in any language. So if it's doable in Perl, I think it's doable everywhere. So maybe that's the reason. And also our Wireless Lab guys also like to know what they're gonna run in their scripts. So once they see they look into the code, they just know what they're running. But maybe they wouldn't have problems with installing with something on their machine or running CLI, but we'll have to discuss them because it's all about security and reliability and maybe about possible configuration of this because we've got some timeouts integrated, but I think Jenkins CLI would achieve the same thing. So just as an example, the only important thing is that this or that way, it's easy to integrate Jenkins job into any existing build script. So any of other departments shouldn't be afraid of integration of whole build jobs into their build scripts or infrastructure. So similar to Michal's remote execution, we used the job hierarchy to test it on multiple operating systems. We do use this kind of script to execute only the master job, and the master job then executes child jobs on all these operating systems, and the virus binary definition gets validated on every operating system, and test results get back to the job and then to the master and then to the Wireless Lab, and they're happy with it because all they care about is true or false, success false, success fail. And that's our conclusion, that Jenkins allows us to run functional tests using Jenkins, to execute them, to get the results and all the stuff around, and we can use it daily as an alternative to big expensive enterprise solutions. And another thing, we think that it's worth executing even small tiny scripts by Jenkins, because with the little effort of configuring these jobs into Jenkins, all this stuff you get for free. You get the test result view, you get the scheduling, you get possible integration into other departments or build scripts, and that's the thing we use on daily basis. So don't afraid to ask Jenkins for help. He's your humble servant. Last but not least, we are here in New York only thanks to these sponsors, so thank you all, and now is the place for your questions. Coming.
Last one more. Do you have any plans to publicize that Perl client that you wrote? So in some other languages, we have packages people wrote for the client Python. So Python has Jenkins API. I forgot the packaging system, but you guys have the Perl has CPAN, so any chance you write the CPAN module?
To answer that, I think I'll have to ask at AVAST. Then I think I would ask you for an advice what could be done better, because this example how to get some stuff done really quickly. So But maybe yes, because we were looking for some API. We found only the Python one. We are looking for Perl one, and if people still use Perl a lot these days, it would be really, really nice to contribute back. Because
I would encourage you to do that. But once you get their part going, the other people can help. But if there's nothing, everyone will be all real again and again. So.
okay.
Actually, now coming to the end, we have a plan to reduce the client and what we're looking at is like right now and we like serialize and one by one because we have thousands of jobs and it takes a long time. So what I'm trying to work on is like they can work on it in parallel. So they can start a job and start job and all kinds of things like in parallel. So yeah, that's actually the our plan. And you actually can check with Yahoo DB and to reduce Perl client.
Okay. So there's one you see on.
Yeah.
So I guess the race is not on.
Okay, and yeah.
Earlier in the talk, did I hear correctly that there were some difficulties aggregating test results?
Yeah, exactly. Michal explained that because we've got the same test executed on different operating systems. That means the master job executes the same set of tests. The results are named the same way. The files are the same, and existing plugins don't give us the opportunity to.
Are these JUnit tests or non-JUnit tests?
No, those are unit tests, but the problem is that if you are running your unit test, you write a class, and then in the unit output there is a class name. And because we are running these same tests with these same class names on the different operating systems, then for us it's hard to understand on which system the same test failed, because we have like let's say 10 almost same files with different test results, but we don't have information about on which operating system this test was run. So this is the problem. That's why we couldn't use aggregate test results plugin.
Yeah, we stick to the JUnit output when we have the possibility. So we run functional tests, but we do create the JUnit output for Jenkins because he loves it.
Did the Matrix plugin have this feature to aggregate those test results? So if you're running stuff on multiple platforms, then I wonder if you have tried that.
Matrix plugin?
Matrix plugin.
No, it's not a plugin, it's a feature in the core called the multi-configuration project.
Oh, we can try that multi-configuration.
I haven't tried it. We just tried downstream build view plugin because it was supposed to solve this problem, but it didn't work.
So you just transport the JSON object as a test result from the machine that you spawned on back to Jenkins, right? Couldn't you doctor up one of the steps in your either Python script or whatever could be inject the host name into it before you copy it back? And is that all you need to know? That which machine it ran on? Would that solve it? Wouldn't it be that simple?
I'm not sure if I did understand correctly.
So
Because
the agent on, let's say, Windows 2000 on a particular flavor is the one that failed the test.
yeah.
Wouldn't that machine that was spawned out that failed the test just identify itself, annotate itself in the JSON object as one more property and spit it back in, and then you would
No, we copy the JUnit outputs. We copy the test result outputs in the JUnit format. We are not using any JSON.
We use the JSON only to execute whole jobs, like to execute the master job. Because we want like one entry point, and we want to have the whole configuration in Jenkins. Yeah, because then it's easy to configure and easy to add other build steps or just test. That's the reason why do we call only the master job here. Any other questions? So I'll add one more interesting point. Once we introduced Jenkins to our company, and we started to run tests on Jenkins, people from other departments started to come to our department and look on these test results, and they liked it. So even those PHP people who are about to write their own Jenkins in PHP now installed Jenkins and started to execute their own builds on daily basis. So maybe if this goes well, one day we don't just write this up and we'll just execute our jobs from their Jenkinses and it's going to be great. So I think that's it. Thank you for your attention.